Good afternoon, everyone. My name is Amith. I'll be making my presentation on impact of reinforcement design on rebar productivity. I would like to thank ISARC for giving me this opportunity, and I would like to thank everyone who has come here to listen to us. So I also like to thank my guide, Koshy sir, and my L&T guides. So background. So in any construction project, scheduling is the most important thing. So schedule is important part of project management because procurement, fabrication, everything is based on that schedule. The initial schedule, whatever the scheduling engineer is preparing. Now, if by chance the schedule is not properly prepared, because the person who is preparing the schedule, he may not know exactly what is the particular structure. He will just have some data, so and so has to be built, so and so is the material required, so he'll make the schedule. But he won't know exactly what is that particular structure. So the schedule may not be accurate. So when the actual work is happening, there will be some delays. This delay will have some subsequent cascading effects in the other aspects in fabrication, all that. So schedules are impacted by unreliable productive estimates assumed during planning stage. So now this variation can be solved due to many reasons. There may be external reasons like weather, labor skill, labor availability, material availability, height, work. One more thing is design. So sometimes when a designer does this thing, I require so much steel reinforcement, he'll provide it. He may not be thinking about how workable it is. So that is also one of the point of design. When not many studies have gone in depth, how is the design affecting the productivity at site. So that is what I wanted to study. Okay. So the site chosen for this study, like the one which I was working on, it is a industrial site which has some heavy machinery, some pipe pumps, large tanks, all that. So the very large dia rebar is used. The spacing is also very less, and in a particular, and it's completely RC wall. There's no block work, so it is not a frame structure. It is a RC structure. So whenever there's any pipeline or any duct has to go through a wall, there'll be openings. So this is one example. We have a door here, then there are duct openings, there are pipe openings. So all over the place there are openings. So we don't have continuous rebar. We'll have pieces. One is that issue. Second is complex shape of structure. It's not a say north south or east west wall. There'll be some inclined walls. There'll be curved walls. So it is a complex shape. So one more thing is floor plan is varying from elevation to elevation. So there's no common slab. Half of the building has one slab, other slab. So there's no common. If it's not repeatability is not that possible in this particular structure that I studied. And one more thing is this design is a specialist contractor. Like it is a item rate contract. We are not. We couldn't change the design. So whatever is the design was done by a third party prior to. We can only just small corrections, but the major changes were not possible. So. So now the goal of my project was, okay, as a scheduling engineer, I cannot go through all the drawings and find each schedule structure, which is more difficult, which is easy. So I wanted to make a tool which will take some data and tell me this structure might be difficult, this structure might be easy. So that was my goal. So to understand the effect of reinforcement design productivity, so that was my goal. So I went to site, I collected some data, actual site work data. So, but while collecting data, I had also think, okay, as I said, there are many factors which affect my productivity. But my concern in this work was based only on design. So I had to eliminate other factors. So what I did was I try for make my base model, I collected data over a span of 2 weeks, which was compact 2 weeks, so that and during that 2 weeks there was no like very high wind or rain or anything. Then whatever data I collected was in the same elevation, the same floor. It was not multiple areas. Then because in the same floor, the stockpile area, the assembly area, like will similarly, we are using tower crane only, so there was not much effect due to those things. Then and there was no effect due to lack of material or manpower or something. The material was available, work was done. I collected the productivity data. So okay, so now as I said, I wanted to predict productivity just based on some input data. So the input data I have is, okay, I know the geometrical dimension of the structure, where the open is coming, what is the concrete quantity, all that. So, and I know what type of reinforcement is coming, all the data I have, BBS details I have. So I also went to site and talked with the foreman and try to understand what are the difficult aspects of in a particular site, all that I collected. So based on this, then I studied some literature. So what I thought was, okay, from the data, I want to condense it down into some parameters. Then I will use that parameters and some data feeding software to make my prediction model. So the parameters, I tried many parameters. based on practicality, based on which is what's more effective, these are the two parameters that I finalized. One is the standard density of reinforcement. This was done in a previous paper also by in another machine learning software also. So density of reinforcement in a sense, what is the metric ton of cubic meter of metric ton of steel that is going to be used in a particular structure by what is the volume of concrete that will be particular that. So this parameter accounts for the dia of rebar. So the higher dia rebar, automatically the density will increase. Close spacing also is included in this. If there are a lot of additional bars, maybe some additional force are coming, some additional bars, all those are accounted in this parameter. But this parameter, just only this parameter, I was not able to get a satisfactory answer. The reason is, so as I said, in my wall, there are a lot of openings. So this doesn't increase my density of rebar as such, because my rebar is also reducing, concrete is also reducing. So I wanted another parameter to account for cases like that. So what I used was non-linearity. That is what term I used. What it basically is, I calculate the total running length of rebar I have to produce for a particular structure. Then I calculate how many bends are there. So if it is a C bar, it's 2 bends. If it is a stirrup, it's 4 bends. So number of bends every 10 meters. For a 10-meter length of rebar, if I have to fabricate for this particular structure, for 10-meter length, how many bends I have to make, that I calculated. So these are the two parameters that I've used. Using this, this is one of the site examples. As you can see, this lot of density is very high. In other case, even along with density, even the number of, because of so many stirrups, this is also very high. So I'll get a bit faster. So I took the curve. I have to find a curve to represent my this productivity. So I used my MATLAB because that was the one which I was more familiar with. So in MATLAB, there is a data fitting toolbox. In that, using the toolbox and scripts, I use this data and I tried different curves. So after I got the curve, I wanted to check which is the best for me. So what I did, I used that curve and I checked actual site data. Like I predicted some data, and at site, whatever the data I was getting, productivity data, I compared it. So two surfaces I found like most fitting. One was using a polynomial model. This is the surface, as you can see. Those are the points that I used to make this data. And another one is the interpolating model. This was not that good for data because my data, you require much more data for this model to work properly. If you had a larger set, this would be better. But I went with this data. So while comparing it, some areas it was coming very good accuracy, but some areas it was varying. This might be due to I am only considering the reinforcement design. Now I'm not considering other factors. So 100% accuracy will not be possible. But this shows that there is some. This is a valid approach. If we have more data, we can get much more accurate results. So after doing this, I also wanted to know, okay, I understand this structure is difficult, but why is it so difficult? So what I did was I used Excel and I classified whatever data I had, the parameters and the productivity I classified into 3 parts and I compared it. So what I found was for a given reinforcement density, so like it's a range, as the non-linearity increases, means as the number of bends increases, the productivity was decreasing. Similarly, for a given non-linearity, as the density is increasing, productivity is increasing. So even though dia bar is increasing, but for given non-linearity, means the number of bends, suppose I have a column, 2 columns, both have similar rings. So the number of the non-linear parity is same because the number of rings, everything is same. But since the dia of one column is more, what I found was, even when I went to site and I asked also, what they say, what the foreman was saying was, erecting of the main bars is easy for them. It's a straight bar, they can erect easily. So even if a larger dia, closer spacing, they have no issue. They have problems when inserting the rings, when inserting stirrups, when there are openings, we have to position the bar exactly to meet the openings. So, so those are the this. So what was my conclusion was, just because the reinforcement dia is more, spacing is less, doesn't mean the productivity will decrease. It might actually even increase. But if you have a lot of openings, if you have small, short walls, if you have a lot of curved walls or sharp bends, then productivity will be hampered more. So, okay, now I know that some structure has difficult, some structure is easy. So what to do with the data? So one thing is you can change the design, but as I said, this site we couldn't change the design at anyway. Once the construction starts, you cannot change design much. So okay, second is change construction method. So construction method, some places we have to. Okay. So construction method. One model with one answer which that was easier to do for me was Revit modeling. Like one of the problems they had was the drawings had only limited number of sections and all, so they were not easy to understand. So I made them on Revit model of a few structures which I was considering as the worst case scenario, which they're going to do in the next month, and I provided to them. So they improved slight improvement productivity, but since this was a very limited case study, we cannot conclusively say it. But this is one like once we identify what is the difficult area, we can provide more thought about it. So what maybe some construction method can be improved, maybe the Revit modeling, maybe some other new idea we can provide. So the idea behind my work is, you before start of work, when the scheduling engineer is doing, he shouldn't only rely on some basic, what is the metric ton, what is concrete. He should also have some design criteria, so that not design criteria, like some additional idea that okay, this might be difficult area, so I have to think more in this area, so I have to allot more time here so that I can pick up any emergency this. So these are the two cases where I just made them the model and gave it to them. This was, I think, some 40-meter wall, and this was some 10-meter wall. So conclusion, that's conclusion what I said again. For light structures, when we have like less than 0.25 metric ton per cubic meter, the bends are not that critical, because even if there is a lot of bends, the site they can easily bend some 12 dia 16 dia rebar, and they can adjust it. When we but number of bends becomes critical when you have heavy structures, because the manipulation of the moving of big bars is difficult. So that is my conclusion, that scheduling engineers should have some data to help him better schedule, so that in the future when actual site construction happens, that will this. So thank you.